Bismillahirrahmanirrahim. Assalamu alaikum. This is Easy Learn. You're welcome to the Easy Learn. Previously on Easy Learn, we are discussing about the magnetic effects and magnetism and its relevant properties, electromagnetism, superconductors. These type of the things are discussed previously on Easy Learn in Introduction to Electronics. This is episode 6 and I am going to present today RailGun. Let's discuss about the railgun and try to discuss and start why it is needed and what is the history behind the railgun and how it is associated with our discussion. US and UK defense workers are developing a gun that can attain extremely high projectiles. So we are first of all interested in extremely high projectiles, and number two is the speed. High projectile here means that we can it is basically the projectiles means that when, for example, we fire a bullet and it travels a distance of to hit the target, this is the projectile, and its motion is called projectile motion, and we are trying to cover the maximum projectile, means that we want to hit the targets from the far away, and it can move basically go through by passing by covering a large distance. This is called projectile, and we are interested in gaining a high projectiles so that if our target is far away from where we are doing this process and we are launching this projectile motion, we can easily hit it and without any difficulty. And we are also interested in the speeds so that our target may be at a specific time we are not sure if it is still here, if it is still there, or it may be change its position. So speed is also very important. It is a totally change in the scenario when railgun is discussed. Railgun is using electromagnets to do these things that I discussed: extremely high projectiles and speeds. Both are interesting facts when we discuss in electromagnets. This story was started in 1845. In 1845, Professor Christian was the first who discovered coil gun. Coil gun, it is the same that is the railgun. Coil gun is discussed because it was first experimented on a small scale in the laboratory and named as a coil, and rail are the basically harder term that is used, very toughest thing, and improved form of the coils and used on the large scale when we are going on defense systems. The earliest electromagnet gun developed was the coil gun. It was developed in 1845, and he discovered this process which a railgun uses, Professor Christian, and the University of the Christian, older name of the University of the Oslo in Norway, is named after him. The barrel of the gun, these are the barrels. This is the diagram. You can see of the diagram of the rail gun. There are the two copper rails along the barrels. This is the projectile. This is the projectile which needs to be hit. Remember that these projectiles are hit with the high speed. So to damage the target and to hit the target with the high speed, don't need an explosive materials. This is a very simple, just simple projectile which does not contains any explosive material. It is just the speed that affects and damage all the structure. This is the high current we need to produce a high electromagnet effect. So for this we are using a DC generator. DC power is used because we are interested in the direction. We want this direction. That if we are using the positive here and the negative terminal downside, then it will go in this direction. If the direction is reversed, as direction is reversed, same magnetic field will be change its direction too. So it means that this is really important. We are using DC current because it does not change its polarity and the direction is constant. 750 kiloampere is very high current. We are using this, and this is the armature which is providing connection between the up rail and down rail. So it completes the circuits. As the circuit is completed, a very high current starts the passing through this one first rail along with the armature, and then it reaches to the other rail, that is the downside, and this generates an electromagnetic force large enough to push this armature up to the barrel at high speeds, very high speed, propelling this projectile from this gun. This is the gun and this is the end of this gun, and it starts its projectile motion. And this is the photograph that is taken from the high-speed photographic camera and at Naval Surface Warfare Center in 2008, January 31. It was a record at that time when this projectile was 3.2 kg and it's 10.64 megajoules were used at that time with a muzzle velocity of 2520 meters per second in 2008. After the 2 years, this record was broken by this in 2010. The Office of the Naval Research Electromagnetic Railgun, located at the Naval Surface Welfare Center, fired a world record of setting 33 megajoules shot. Here it was 10.64 megajoule, and now the record is broken by setting 33 megajoule shot. And this is the basically a picture taken when it was the record setting moments. And these are the some drawings of the electric gun, railgun, or the linear motion cannons projectiles from a German report newspaper. And it, as I explained, in these electromagnetic railguns, this is no need of explosive materials. They are just designed to hit the target at the right spot, because accuracy is also very important issue, as well as speed. For the sake of the speed, the railgun is responsible, not the projectiles. Magnetic hydrodynamic propulsion. A magnetohydrodynamic drive, or MHD, these are the same things. This is the short form of these and this term. Accelerator is a method for propelling vehicles using only electric and magnetic fields with no moving parts. Can you imagine a vehicle with had no moving parts like pistons and these type of infrastructure? We are trying to create a specific mechanism which uses electric fields and mechanical fields. Like in the previous case, railgun uses no mechanical parts involved here. This is just a process that involves here electric and mechanical electric field and magnetic fields. So we are trying to use the same process here in the vehicles. This was first experiment performed practically by the Japanese industry. Mitsubishi Group is building a prototype ship that will be driven by electromagnetism. The propulsion system, called magnetic hydrodynamic propulsion, MHD, has no moving parts. This is the main thing they are trying to do with this ship. But the main, I'm not going in details of this system, but I want to show you that this system is basically consumes too much power, and we cannot compromise on the waste of the power. They did this by heating the seawater, and this is the part of their procedure. But this is unlikely to be used in the commercial, because of course we cannot compromise on the efficiency, and it is only used if we can, scientists can increase its efficiency. And this is the ship that the Mitsubishi experimental boat named Yamato 1 with magnetohydrodynamic drive. This is the end of the episode, and we will discuss further discussion inshallah next time. Take care. Allah Hafiz.